but this is a relatively new thing for the eastern coast,
It
right?
is.
So will this turn the tide and make people suddenly think, well, I think I better figure out what's going on with climate change?
Welcome to Facing Future. Today, as wildfires burn in Canada and hazardous smoke fills the air in much of the northeastern United States, I'm joined by two members of the Facing Future team, scientists Paul Beckwith and Patrick Hogan, to look at why this is happening and what it bodes for the future. Paul, you're in the thick of it in Ottawa. What are you seeing?
Well, Canada had an exceptionally warm and dry spring. In fact, many parts of the the northern half of Canada, both on the west coast and the east coast, had the warmest May in at least 84 years, based on reanalysis data from U.S. and European data. And as a result, the top layers of the soils, the top 7 centimeters, the top few inches of the soil are the driest ever, in those regions. And so any spark, any trigger from either humans or from lightning initiates these fires, and they're just springing up all over. Typically with wildfires, about 50% are human caused, things like cigarettes out windows, not putting campfires out, sparks from, the metal wheels of a train on the track, that was, or other human reasons. About 50% are wildfires. About 50% are lightning caused. Most of these in remote areas of northern Quebec are caused by lightning in this particular case. So 150 fires in Quebec alone, 110 out of control still, and about 450 across Canada. Now, off the east coast of the U.S., there's a low pressure. Air moves into that low pressure, deflects to the right in the northern hemisphere, so you get a counterclockwise rotation. And the upper part of that low, that rotation is bringing air down from the north to the south. So it's picking up the smoke from those wildfires. It's carried it through Ottawa for the last couple of days. Today is great, but the last 2 days, and then carried it to the eastern seaboard of the U.S., where it's greatly affecting, all the major, hundreds of millions of people, I guess, Boston, New York City, Washington, Philadelphia, all of those places. And then after crossing those cities, then it goes out into the ocean from there.
Well, we're seeing spectacular footage from Statue of Liberty, from New York City, orange, skies everywhere, things we have never really ever seen before. I don't know what happened in the Dust Bowl. I know there was something like this, and that when that came to Washington, D.C., and they finally had dust in their own windows, they finally started to take action and created kinds of farm measures to protect the soil, which have fallen by the wayside in the meantime. But so hopefully this one, which is moving to the centers of power in the United States, will be something of a wake-up call for our incredibly asleep legislators, who don't seem to really understand the full extent of the catastrophes that are, rapidly coming upon us.
Well, we continue to warm the planet. We have not interrupted that progression as a planet. So even with all the UN COP efforts to discuss this issue of climate change and somehow calm it down, we haven't taken any significant steps there. So things continue to warm. And this is what's given us the droughts, and the droughts that prepare the forests for very aggressive burning. And so that's what we're seeing now, is these trees that have been weakened by drought that now catch fire become very difficult to put out. So, but even worse, it's also that smoke actually goes up as particles. And yes, it does enter our atmosphere that we breathe, but it also falls to the earth at some point. And up in the northern area where most of the smoke is, at least that's where it starts before it comes and visits us, due to what Paul has explained, those particles fall out of the air and they are sitting on snow. They're sitting on glaciers. They're sitting on Arctic ice. Ice and snow reflect the sun's heat and light by 90%. Once you have darkness on that snow or that ice, you now are accelerating the melting of that ice. And once you've accelerated the melting of the Arctic ice, you go from 90% reflectance to black water, which is 90% absorbance of the sun's energy. That's almost a 200% turnaround of what the situation's experiencing. So we, as a result of not dealing with climate change, are actually causing it to accelerate dramatically and with an increasing pace over time here.
I'll just expand on that a little bit on what Patrick has said. So a paper has just come out and hit the news yesterday about the Arctic sea ice, because just a few years ago, scientists were saying, it would last in the summer until about 2070. So this new research is showing probably by 2030, it's gone in the summers in the Arctic sea ice. So, Patrick was talking about how the albedo or reflectance changes. And yes, open ocean appears very dark, and most of the light gets absorbed into the ocean, whereas when you have a bright white surface from the sea ice or snow on the ground, it reflects. So the Arctic overall is getting a darker place. It's not reflecting as much sunlight. So this is a huge accelerant to polar amplification and to climate change in general.
Yeah, so Earth's air conditioner is now becoming Earth's heater because of the warming that's going on in the Arctic. Is 2.5 times, 3 times faster than anywhere else on the planet as a result of these things that you've just described, Paul. So yeah, we're in some very difficult territory in terms of readjusting things so that we have the climate that we've had for the past, 10,000, 12,000 years.
The fine particles that we are now experiencing, and we're told to not go outside because it can get into your lungs, can affect your heart. It can have, long-term effects on your health. It can even affect your brain. These particles are something new to us, but in other parts of the world, it's even worse, and on a daily basis. So, we are maybe there's some empathy here for this moment because, say, in Delhi, in India, this is a daily occurrence. And I don't know where else in China, probably as well, other places.
Yeah. So that's a very good point. We're probably setting records, in Canada, Canadian cities and US cities on particle counts and on record poor air quality. But this is from the fires, and it can change quite a bit, and it's not going to we're going to be shrouded in smoke all summer. There's probably going to be periods of time that are just as bad as we've had in the last few days. But yeah, if you go to many cities in India and China, they have this. It's not from wildfires; it's smoke from industry. And they have it day in, day out. And, these PM 2.5 particle matter, 2.5 micron diameter or smaller, these particles are horrible for human health, not just human health, but any animal's health. And we're finding more and more about what these things do. We all know probably about coal miners' lung disease, black lung. Working in coal mines, you get particles in your lung. It shortens life expectancy. Asbestos particles, small particles, can get lodged in your lung and cause cancers. These these are small carbon particles. Some of them combusted. They're more like the ash, very small ash particles, but others are just carbon that from incomplete combustion. And these small particles, they go very deep into the lungs as far as the alveoli, where there's an exchange of oxygen and CO2 with the blood. And these particles, as you know, as Patrick said, get right into your bloodstream, and then they can travel to all of your organs. So, for example, the placenta in a pregnant woman, these particles have been detected and going through the walls of the placenta into the developing fetus, also into the brain. They've been detected going right into the brain. And they basically have been detected in just about every organ of the body, including the reproductive organs, you know, the genitals. They go in, they're in everywhere. So, and you know, they cause a myriad amount of health effects. You know, they enter the heart and cause cardiovascular disease and stuff. So basically, you know, if you look in India, in these cities where the counts are very, very high, people there are basically living a decade or two. They're living lives that are shortened by at least a decade or two. So there's huge health effects from these small particles. And to give you an idea, so Ottawa today is very, very good air. The air quality index is 14, and the PM 2.5 concentration is 2 or 3 micrograms per cubic meter. And the air quality index depends on the PM 2.5, the ozone, and the nitrogen dioxide. The index is determined from those 3 concentrations. So it's very good quality air in Ottawa today. Now, yesterday was the worst we've ever had, I'm sure, probably the worst seen in Canada. We reached over 500 on the air quality index. I think 507 or something like that. Which is, you know, the particle counts of PM 2.5, which is the biggest thing created by the fires. It's in the smoke. You know, those concentrations were enormous. Like they were approaching 500 micrograms per cubic meter, and here we are, you know, 2 the day later. So 500 one day and 2 the next day.
That's not called climate change. That's called climate chaos.
Yeah. It's like, but the thing about this smoke is it's in your face. It prevents you from exercising. I highly recommend people wear masks outside. They're very, very effective. You know, don't forget about your pets. Try to, you know, always some of the smoke gets into your house, but it's much lower concentrations. HEPA air filters are very, very good. So make sure you have at least a room in your house where you can go and run your HEPA air filter and have very, very healthy situation. So my HEPA air filter filters out all particles, 99.99% of particles down to 0.3 micron. So the PM 2.5 or 2.5 micron, right? So I can go a factor of 10 lower and filter out all of those particles with the HEPA filter. And these things are widely available at hardware stores, etc.
I have 2 of those, but I didn't think of putting them on yesterday. My eyes were stinging. You just don't think, you don't think at first what to do. And even indoors, I have one that measures what's happening, and it was like the worst possible quality air. And, after the filter, it was better. But even inside, even downstairs where the windows were closed, we were still having, infiltration, because these particles are so tiny. It's really amazing how they can get inside of your house and of course inside of your body. But we'll get over this. The fires will stop, but in other parts of the world, they will not get over it. It's a continuing problem, literally killing ourselves with our industrial processes. We do know that if we could restore more of nature, but then of course they have a fire. So the forest is there and now the forest is gone. That's really so depressing.
Over Canada is up to 4 million hectares of forests in Canada have burned already. And that's, that's like orders of magnitude more than last year, say.
I believe that's the same amount that's on fire in Siberia right now as well.
Yeah, I mean, multiply by 2.57 to convert hectares to acres, right? So it's like 10 million acres of Canada has burned. It started with Alberta, and it's worked, and then the fires in Nova Scotia hit the news because one was right near Halifax, the city of Halifax, and destroyed over 200 structures. And then, and now it's like northern Quebec is really the focus, but there's also still many burning. The other thing that's important to remember is that I don't know if like there was an ice storm in parts of Ontario and Quebec beginning of May, believe it or not. Not that long ago. We're only beginning of June.
Yeah.
So beginning of May, there was an ice storm. And it knocked out power in Quebec to 1.2 million people. And it took down huge numbers of branches and caused the worst damage in Quebec. We had it in Ottawa too, but it was a 3 or 4 hour event of freezing rain in Ottawa. It was at least double that in Quebec. So the power that's knocked out is mostly falling branches and falling trees. Sort of late May, 1 year ago, we had what is called the derecho, which is straight line winds come across, and they caused tremendous damage to trees in Ontario and Quebec. And they knocked down branches, knocked down trees, very, very high straight line winds, high velocity straight line wind. So all of that is basically, and now that's just lying on the ground for a year. And then with these very dry conditions and very little rain, they dry out, and it's perfect fuel for all of these fires. So all of these, so climate change is a very cumulative thing, right? It's not just one thing. It's when all of these different things, go wrong for you, conspire, and then you get these problems. So I talk often about the climate casino. If you're in a city or a town and you're unlucky in the climate casino, you get the flooding, you get the, massive severe weather event, storm. With these wildfires, the actual damage from the fires is, hitting very few people compared to the number of people that are affected by the air quality. Right. Mm-hmm. So, 200 people lost their homes in Nova Scotia, many more people in northern Quebec. It's a lot of isolated regions, but there are towns that are being evacuated and homes lost. But it's small numbers of people compared to this vast plume of smoke, which then travels thousands of kilometers, thousands of miles, and, affects many, many people, in like how many people are in New York City? 20 million or in that region, or
I'm not sure.
I don't know. So I don't know if I can call it a climate casino when it's affecting the entire eastern seaboard with smoke, right?
Well, last year it was the western part of the United States, San Francisco, Oregon. People were like in their houses, and people that I knew were saying, "Well, I've got all these air filters on, but I have to put stuff on the windows because the particles are so tiny that they can get in." And the wind, pressure in your house might be different from the pressure outside. Suck it in at that moment. So, it seems like these catastrophes, they kind of sets the stage for the next thing. There's a drought, dry land, doesn't absorb water. Then we have a flood. The flood has nowhere to go. I'm wondering, fires in Canada, but, they're huge. There's the Adirondacks, the Catskills, all these, forests that we have that are so wonderful, but aren't they going to be as equally threatened very soon by the heat?
Yeah. I mean, it seems that we're crossing a threshold for fire behavior, because the wildfires are not only are they the wildfire season is much longer, right? So they're happening. We're getting them a lot earlier in the spring, as you mentioned. California had terrible fires just a few years ago. So people in the West, they got used to sort of having to wear masks outside and having safe places in their home with good air quality. but this is a relatively new thing for the eastern coast. So, will this turn the tide and make people suddenly think, well, I think I better figure out what's going on with climate change?
Dale, we're getting so many clues as to what the results are of a warming planet and all these climatic disasters. And yet, we keep getting these clues, and they're world-sized clues, planet-sized clues, and yet Homo sapiens, wise Homo, is acting like Homo stupidus, because we're getting these clues and we are ignoring them as if, well, we'll just keep on doing the same thing we've always done and expect it to change. But it doesn't.
Yeah, and see, the problem is we've got this El Nino that's developing, and if it becomes super El Nino, it's going to these problems are going to be exacerbated. I mean, we're getting all of these effects with about 1.15 degrees Celsius above the 1880 to 1910 climatological average, and we've warmed since 1970 to 2010. We've warmed about 0.18 degrees Celsius per decade, but since 2010. The slope of the warming has increased to between 0.27 and 0.36 degrees Celsius per decade. This is all outlined in James Hansen's recent paper, Global Warming in the Pipeline. And one of the big factors that's causing this acceleration of the warming rate is reduction of sulfate aerosols in China and also in the commercial shipping industry. So the International Maritime Organization has tightened the regulations on sulfur content in fuels. It was about 1% reduced to 0.5% sulfur, and now 0.1%. And they tightened the emissions in 2015, and you can see a strong uptick in the so it's cleaned the air, and these particles cause some sort of cooling blanket, if you like.
Yeah.
But because there's fewer of them since 2015, we've seen a strong increase in the Earth energy imbalance. And this is the main reason why the slope of the warming curve has increased after 2010.
Well, Jim Hansen's courage and his endless campaign. I mean, his heart must be so strong to have started in 1988 to warn people, and to see what's gone on
in Congress.
Since. In Congress, to testify before Congress very strongly, and to be completely really ignored, even by the Conference of the Parties, the UN. I mean, they 28 meetings, and still the arrow's going up. And as you say, Paul, the renewables are not replacing fossil fuels. We're just energy hungry species that keeps adding and adding. Oh, we can have more and more and more. So, we can't have more and more and more. We need to have less and less and less. And this is one of the hardest things for people to recognize. Well, what do I do? Do I get a great new big EV, SUV? No, you drive less. You don't drive at all. You don't fly to, somewhere, and, you keep your energy consumption low. We're not going to be saved by, an amazing transition to electricity, because we've so polluted our planet at this point.
I mean, the thing about the smoke is it's hard to ignore, right? Like a government can't ignore it. I mean, CO2 can still be rising like crazy. Methane, you can't see it, right? It's rising. The warming is occurring around the planet. It's increasing the warming rates, et cetera. But, we still do it. Government still subsidize the industry, so it's still done. Yeah. But when you have the wildfire, when you have the smoke choking out cities, making them look like dystopian, it looks like these buildings are on Mars, for example.
Well, we are entering into a reality that we only imagined in movies before. And unfortunately, a lot of the worst things that were just science fiction before are now realities. And, we hope that this smoke will create some kind of awareness, will wake people up to some extent. But, if it doesn't, then more fires and more disasters are coming. And it will, as we all know, reach a point where the tipping points are so triggered that we can't really reverse it. And,
Well,
you know,
to put
thank
this
you.
into context as well, with what's happened in the past, there was a time called the Paleocene-Eocene thermal maximum. And the temperature rose very, very quickly. And it looks like that what in the paleo record, you can measure the carbon in the ocean sediments, which is used to go back to figure out what's going on at that time. And it looks like, there was just massive, of course, uncontrolled burning of vegetation on the surface of the earth, which then added to this huge spike in the record. So also we had a period on Earth called the Carboniferous, where there was, vegetation, huge vegetation covering lots of the planet. And what ended that period, because of the high amounts of vegetation, the CO2 level, the oxygen levels in the atmosphere were higher. So we're at 21% right now. They were as high as pushing 30% oxygen levels in the atmosphere at that time. So you can imagine how much hotter and widespread the fires would be with a higher oxygen level in the atmosphere. I mean, take it to the limit, 100% oxygen, that would be the Apollo 1 catastrophe where the inside of the command module just caught fire and killed the 3 astronauts during the Apollo program. They had 100% oxygen environment. And then on the other hand, there's been periods of time in Earth's history when it's been much colder and the oxygen levels are down to about 15% or so. And, you can climb up a high mountain, and experience 15% oxygen concentrations or even lower, if you climb up to the top of Everest, for example. Right. So you can experience those sort of things. So there's very few fires up on Everest. Well, there's very little vegetation, but if there was, it wouldn't be burning anyway because the oxygen levels are much lower.
Well, we live on a very volatile planet, and we live on a planet with many, many changes and volcanoes and hurricanes, and now we've increased it with what we're doing. Anyway, it's great to talk to both of you, and thank you so much for your work and for being in this program today.
Thank you.
Likewise, Dale. Thank you for yours.